Today I am going to tell you about the equations which are related to certain numerical problems, and these problems are related to the chapter force. We can use this equation to solve the following terms, just like gravitation force, and gravity or gravity force, and acceleration due to gravity, and weight of the body. Out of these four, gravitation, gravity and weight are the forces, but acceleration due to gravity is simply the acceleration, but it is produced on a freely falling body due to the gravity of the earth. Okay, now I am going to present all this. Number one, we can use this equation F equal to capital G m1 m2 by d square. In which case we can use this equation if two bodies having mass m1 and m2 are separated by a distance d, and we have to calculate the gravitational force between them, then we can use this equation. But instead of this, we can see these terms of the equation also, F, m1, m2, d and g. Out of these five, if any four quantities are given, fifth you are asked, then you can use this equation to solve the numerical problem. Okay, we have to remember that if two bodies are separated with certain distance d, then this equation is useful. Now next, second equation, F equal to G, capital G, m by r square. Now in which case we are using this equation if we have a huge heavenly body, maybe a planet, maybe earth, maybe a satellite also like moon, and its mass is capital M, and if a body is lying on its surface having a small mass represented by small m, and they attract each other with certain force, that is gravitational force. If we have to calculate the gravitational force between very huge mass and another mass, small mass, then using the radius of the huge mass we can calculate capital F. I mean to say gravitational force between them. That is F equal to G m by r square. Okay, let's go to third one. Acceleration due to gravity, small g equal to gravitational constant capital G and small m divided by square of the radius. In which case we are using this if we have a huge heavenly body, maybe earth, moon or maybe any planet also. Its mass is capital M and its radius is r, and in this case if we have to calculate the acceleration due to gravity on its surface, then we can use this equation. Now let's go to next equation. G dash is equal to Gm by r plus s whole square. In which condition we are using this equation if we have a huge heavenly body having mass capital M and its radius is capital R at certain height h from its surface. If we are going to calculate acceleration due to gravity at that height, then we can use this equation, and acceleration due to gravity at that height is denoted by G dash, and if we have to calculate G dash we can use this equation. Okay, let's go to another one. This is F equal to mg. F equal to mg. F means force, and this is also called weight of the body. In which condition we are using this F equal to mg. F is here we can consider as weight of the body also. Let's say this is earth and a body is lying on its surface, its mass is small m, and it is attracted towards the center of the earth. Attraction force of the earth acting on a body lying on its surface is the weight of that body. Yes, and this weight is force and can be denoted by F. And how much is the acceleration on the surface of the earth? We can consider this as 9.8 meter per second square, and we can calculate capital F, I mean to say the gravitational force of the earth acting on the body, and this is also the weight of the body on the surface of the earth. In this case we can calculate the gravitational force of the earth acting on the body or weight of that body on the earth. These are the equations which we frequently use to solve different numerical problems related to the chapter force, and especially it is used to calculate gravitation, gravity, acceleration due to gravity and weight of the body. Okay, this much for today.